So today we're just going to go over the basics of an infinite geometric sequence. So you already know a basic geometric sequence probably. You've got 1, 2, 4, 8, 16. This is a geometric sequence. It's different from an arithmetic sequence because each term you're multiplying by a constant n, or actually we'll call it a constant r. A constant r. And in this case, this r is 2, so r equals 2 here. So now what happens when you have an infinite amount of numbers here? It keeps on going forever. If you wanted to find the sum of that, well, in this case it'd be impossible since 1 plus 2 is 3, 3 plus 4 is 7, 7 plus 8 is 15. It keeps on getting bigger, so it'll never converge. But in some cases, we're going to have when r is less than 1, let me give a sequence like that. So let's say we have 1, 1/2, 1/4, 1/8, 1/16. So in this case, the common ratio r is 1/2. You're multiplying by 1/2 every time. So in these cases, when you sum it, if you note it, you'll notice that the sum is actually it's increasing by a smaller amount every time, right? It starts at 1, then 1.5, then 1.75, and if you keep going with a calculator, you'll notice that it's pretty close to 2 after an infinite amount of time. So now there's actually a formula for this. To find the sum of an infinite geometric series where r, the common difference, the absolute value of r is less than 1, since that way it'll converge. In order to do that, we have the formula a1 over 1 minus r. Now a1 is the first term that's at the beginning of the entire sequence, and r is, as we said before, the common difference. So in our previous example, 1, 1/2, 1/4, 1/8, 1 would be a, and our common difference is 1/2. So in this case, we can prove that a1, 1 over 1 minus 1/2, is equal to 2. So there's that. Now let's try an actual problem with infinite geometric series. The Pete's Pirate ride operates like a pendulum. On its longest swing, the ship travels through an arc 75 meters long. Each successive swing is 2/5 the length of the preceding swing. If the ride is allowed to continue without intervention, so I guess that means no friction or anything, what is the total distance the ship will travel before coming to rest? Okay, so first let's draw this out. So here's the thing, and it'll go all this way, 75 feet on its first swing. Then after that, it will go back to somewhere around here, right? We'll say this is 2/5, although that's really not, that's terrible. Yeah, so 2/5 of 75 would be, what would that be, 25, 15, 30, right? So it goes from 75 to 30 to then 2/5 of that is 12, and it keeps on going, right? So now we need to find the total distance that the ship will travel, which is just the sum of all these. So let's use our formula. If our first one is 75, and our common difference is 2/5, not 1/5, 2/5, then we shall use a over 1 minus r is equal to 75 over 1 minus 2/5. This is equal to 75 times 5/3, or 125. And we're done. So maybe next video we can do some harder problems. If you want, just let me know in the comment section.